Although, of course, when we view at this angle, now we can only see one eye, nose, and part of the mouth. We're still able to recognize it as a face. Well, when NASA was tasked with imaging this object, because there was a lot of public interest, they assigned it to JPL that was operating the spacecraft. And JPL at first refused to take the image, but they were prompted with enough extra funds and bribery that they finally did take it. And they took it under very unfavorable lighting circumstances and a very unfavorable viewing angle. Basically, they were well off to one side of the face, so we were looking at the face from approximately the angle we see George here, and couldn't see across the nose ridge at all. But at least they got us a high-resolution image of it. Now, before I show you that image, let me say how, in scientific method, we judge these matters. Scientific method is the way scientists tell whether things are accidents or significant, whether things are artificial or natural, and so on. We use what's called the a priori principle, which basically states that the odds of something arising by chance are significant if calculated before any evidence of its existence is known. And the opposite of that is an a posteriori finding, which means that you don't predict the odds of something until after you've already found it. In that case, the odds are not significant at all. The calculated odds of something already found arising by chance apply only to the next example, not to the one already known. For example, let's say you're playing a game of bridge and you're dealt 13 cards and you get all 13 spades in the deck. A remarkable hand indeed, and the odds against being dealt 13 spades in 13 face-down cards are 635 billion to 1 against. Okay? So you say, well, gee, there must be something funny going on there. But in truth, every time you're dealt 13 random cards and you pick them up and look at them, 2 of clubs, 3 of hearts, 5 of spades, and so on, 13 random cards, but 13 particular cards, the odds against your being dealt that particular hand of 13 cards are the same, 635 billion to 1 against. But every deal is a miracle then. This shows that it makes a big difference whether you pick up the hand and say, gee, the odds against this are enormous, must be something going on here. No, you can't do that. That's a posteriori. No scientific significance. But if the hand is dealt face down and you say, I predict that that hand is going to contain the 2 of diamonds, the 3 of clubs, the 5 of hearts, and so on, and predict all 13 cards, and the cards are turned over and they're right, you can be darn sure that was no accident. So, as applied to the face on Mars, here is the inset shows the Mars Global Surveyor spacecraft's first image returned to Earth as the spacecraft actually saw the face on Mars. And as I said, it's viewing from one side, so we can hardly see anything over the nose ridge, which is here in the image. But we see the eye socket on our side very large, and the mouth featured very prominently. And the lighting is coming at a low angle from under the chin. And you know how when you put a flashlight under a human face, under the chin, the face looks a little distorted by the lighting. But nonetheless, the main features, especially the symmetry of the mesa, are there. And more importantly, because it's high resolution, it gave us a chance to test the predictions that had been made in advance, before anybody had this data, before anybody on Earth had this data, about what should or should not be seen if this was artificial versus natural. And the thinking was that all we could see in the Viking image was the impression of an eye, of a nose, and a mouth, and a symmetric mesa. But if somebody intended to portray a humanoid face, they would have probably, especially on this scale, 2 kilometers high, which is 100 times higher than the biggest faces on Mount Rushmore, by the way. They would have gone to a little more trouble than that, and probably they would have added secondary facial features, which are on all humanoid faces, such as eyebrows, irises, nostrils, lips, and so on. So predicted in advance that high-resolution image would show up, eyebrows, nostrils, irises, and lips, but that still isn't sufficient for the scientists, because in a noisy background, you can always pick and choose things that look like these things and just happen to fit your preconception of a face. So a second condition for it to pass this test is that there must not be any other objects except for the iris, which is a circular shape. There should be no similar features exist in the background that would allow us to pick and choose the ones that just fit our preconceptions. Then, if we see something that looks like an eyebrow that is about the right size, about the right shape, about the right location, about the right orientation, and there are no other objects that would pass in that way, that's significant. And so we have a number of these. These tests, each one has long odds against passing, anywhere from 10 to 1 up to 10,000 to 1. And the actual odds I will show on the next slide. This slide is the image that I just showed you as passed through 2 filters and averaged by the Jet Propulsion Laboratory and released to the press the same afternoon that image came down to Earth. And what's been done here, and you can go to this website and you'll see the original spacecraft image, you'll see the recipe they used to get this image, and you'll see this image. And the recipe said they put it through a high-pass filter to wipe out the high-frequency detail, low-frequency detail. They put it through a low-pass filter to wipe out the high-frequency detail. They averaged the two with the detail removed, and that's this. And then they said, look how flat and featureless this is. You'd be crazy to say that was a deliberate attempt to portray a face. And when pinned down later as to why they did this, they were very candid. They said, because we're certain that this is not anything but a geological feature, and therefore we are wasting public funds, and it is a slap at the integrity of the scientists to continue pressing NASA to take images such as this, and we object, and this is doing the public service by preventing further wasting of funds and scientists. Now, just to emphasize the point, they put this thing through a high-pass filter, and from Adobe Photoshop, here's the definition of what that does. It retains edge details where sharp color transitions occur and suppresses the rest of the image. The filter removes low-frequency detail on an image, useful for extracting line art and large black and white areas from the scanned image. Why would you want to put an image where detail was everything through a filter that removed the low-frequency detail and then put it through a filter that removed the high-frequency detail and then averaged those two? By contrast, the Society for Planetary Study Research engaged some scientists who were experts in image processing, and they said, well, we've got several views now between Viking, which saw the face about a dozen times, and the Mars Global Surveyor view. And so we are able to triangulate and know the three-dimensional structure of the face. So it said, put all this in a computer. The computer is not programmed with any knowledge of what this is. It's just points of light on images. But we told the computer to then take the three-dimensional information about the points of light and reconstruct what the image would look like if viewed from overhead and with high-angle lighting instead of viewed from the side at low-angle lighting as actually occurred. And let me enlarge that. All right, this is a negative of the actual spacecraft image, and the short animation I'm going to show is what the computer did to first just take this as an image of bits, not with respect to any content, and correct it for the lighting, which you'll see happen first very quickly, and then correct it for the orientation and show what the reconstructed object actually looked like.